Hi, I'm Bruno Aziza, and today I'm sitting down with Dave Mariani at Klout. Dave, thank you very much for your time.
Nice to see you again, Bruno.
Nice to see you. We're going to talk about three things today. First, we're going to talk about what Klout is. We're going to talk about how you use big data to win, and then we'll get into the details of the implementations and some of the lessons that you've learned. But before we get into all of that, tell us a little bit about your background. This is not your first tour with big data, so tell us a little bit about where you come from before Klout.
Yeah, before I joined Klout, I was at Yahoo, and at Yahoo I ran data engineering and analytics for all of Yahoo.
And so how much data did you have to deal with at Yahoo?
Well, at Yahoo, there's lots of data, not just from the consumer websites, but also all the advertising that happens. So that's about 20 terabytes of data a day that we have to process and make sense out of. And so that was, by definition, big data. And we used Hadoop, where Yahoo really was a chief sponsor for the Hadoop and Hadoop community. And we married that with business intelligence and BI, so we could do really great analytics to drive the business.
And so you have your fair amount of success and failures with big data. You've tried many things, and then you came to Klout. What is Klout? What do they do? And what's the business model?
So at Klout, Klout helps people understand and leverage their influence. And what does that mean? It means that social media is an amazing platform for people to interact, but it's also a noisy platform. So at Klout, we have three customers that we're helping. The consumer, we help cut the clutter and give them a platform, give them a stage for them to build their own personal brand, to become better social media citizens. For brands or advertisers, we help them reach influencers at scale. That allows them to do word-of-mouth advertising at scale, which is really a first. And then finally, our data partners, they use Klout data to be able to help and differentiate and offer special discounts and goods and services to customers that are going to promote their brand.
So you're really at the center of a very interesting ecosystem here. First, the individual users, people that use LinkedIn or Facebook, Twitter. You have a way of aggregating all that data, and you serve over 100 million users today. So we're talking a large amount of data.
Yes.
That secondly, you're enabling the brands to reach out to those influencers through campaigns. And then third are those partners. Now, it's interesting because here, with your technology, you're able to bridge the gap between the very physical world and the digital world as well. Tell me about the Palms hotels and how they use your technology today.
Yeah, as a data partner, Palms uses our Klout score to be able to determine for their rewards program whether they're going to give a particular person a room upgrade. So that's a case of the online influence creeping into the offline world and having real value for our consumers.
So I don't know if you can imagine that, but as you're walking into a hotel, the person checking you in being able to know how influential you are, what your influence is for, and being able to kind of adapt their offer based on that information, which is quite powerful, and I'm sure many of the folks watching us envy that kind of marketing model. Now, we've talked a lot about big data and the implications of that and how it works with Klout. Now, you're also a startup, and so I want to understand, how did you architect the solution to scale to such a large number of people, 100 million plus, and so much data calls being put through your system on a daily basis?
Yeah, at Yahoo, Yahoo is big data, and big data at scale. So a lot of the lessons were learned, working for Yahoo and working out those problems. Well, Klout is also big scale. As you mentioned, we score 100 million users a day. We collect about 1 billion signals about their activities on the social networks a day. We serve 20 billion API calls. So you're talking about quite a bit of scale there. And so we use both a combination of open source and commercial software. So open source wise, it's all about Hadoop.
Now, you said that earlier. For our audience, can you define what Hadoop is so we're all clear here what we're talking about?
Yeah, Hadoop is a scalable network of commodity hardware. So it's effectively a distributed disk drive where your data is distributed across multiple nodes in a cloud. What that helps you to do is it helps you to horizontally scale data. So you can, if you want to grow your data and do more processing at a faster speed, you can add additional hardware, additional nodes to that cluster to get more capacity and to get more computing power.
So this is the concept of distributed computing across multiple nodes and the ability to bring in lots of data so you can crunch through it much faster. So in your case, so you're using Hadoop, that's where you start with because of the massive data. And then what else do you do?
So it's all about capturing the data at scale and then storing it without losing our granularity. Because all that data is rich and it tells us a lot about what users are doing and how we can make their lives better and how we can reach them and match them up with the proper offers from the perks perspective. So Hadoop allows us to store that data, capture and store it and process it very inexpensively. But the other part of it is doing the analysis. And you hear a lot about NoSQL databases and open source technologies for processing big data. But from an analytics perspective, the tools just aren't there yet. And so there is where we use Microsoft Business Intelligence to create the ad hoc query environment on top of that big data infrastructure and be able to query data at scale in a few seconds, at sub-seconds or a few seconds, less than 10 seconds time frames.
And this is what's probably interesting to many of the folks in the audience here is that often we talk about big data and we talk about analytics and we think these two things are not related, but in your case, like it is the case of most organizations, yes, you do have the problem of getting massive data at scale, but you have a more important problem would say to get real-time access to that data and being able to build models on it so you can act on it. Now, how do you fix the bridge between the open source software and the commercial software? How do you architect that?
Yeah, so open source, we use open source where possible because of obviously it's less expensive. But when it comes to an interactive query environment for open source, for big data, there's not real good solutions out there. So we take Microsoft Analysis Services and we have it talk to Hive to be able to use Hive as a central warehouse to basically store our data, but use analysis services to query that data. So it's a perfect marriage of really open source with commercial software, which is compatible with all the different tools, visualization and reporting tools that exist that we want to use.
So you've got a nice mix here where you've got openness of the platform on the back end, I would say, with the ability of getting the data, and you've got openness from a query tool where you can work with the data, analyze it, and work with it. Now, I think in part of our conversations, you mentioned how you use the analytics or the data. There's three major uses. What are those?
So, there's the first thing is that we just want to monitor our ecosystem. And so we're taking in those billion signals a day. And so we want to be able to measure and monitor that we're doing the data collection correctly, that we're not missing data, dropping data. So we use analysis services in the Cube to be able to track the changes day over day or week over week in that data so we can discover patterns and drops or anomalies and be able to correct those. Same thing with the score. We have a population. We want to make sure that that population of scores and those people are the scores moving in a fashion that we can explain. So we use it for monitoring, number one. The second use, of course, is that we have a science staff, and pairing science with data allows us to add value to that data, the value through a score, through topics. So our scientists use the Cube and use that warehouse to be able to model their changes and model the effects of changes to scoring algorithms or to topic detection algorithms. And then finally, we used that Cube and that data to look at patterns across the social media landscape. So because we see so many different networks, we can come up with insights that really nobody else can see.
So the relationship between a LinkedIn or a Facebook and the value of the data coming through?
So what's the value of a Facebook like versus the value of a Twitter tweet? Does a retweet behave like a Facebook comment? And you'd be surprised, there's big differences between those platforms and how people interact with those types of signals.
So we've talked about an interesting process here. Obviously, the ability to get the data, use open standards to do that, the ability to mash commercial solutions like the Microsoft solution and get analytics to allow you to better your data, but also better your models and so forth. When I'm listening to you, it seems like this is a fairly complex process. You must have 150 people working on this problem for months and months. How do you organize your team today?
So, we don't, right? We're a small startup and we have to watch our pennies. We really came up with an organization that takes advantage of the different skill sets that were required along along the continuum of big data and analytics. Yeah. And you'd be surprised because the skill sets are very different. So first of all, we have our data pipeline team, which is responsible for the capture and storage of the data. Okay. So their skill sets are around Hadoop and HDFS, which is the Hadoop file system, and tools like Pig and MapReduce to do data transformation and data normalization. So they're responsible for capturing and normalizing and storing that data at scale. Then we have our science staff, and our scientists are PhDs, they're math wizards, they're stats guys. Their skill sets are all around natural language processing, around doing modeling and data modeling at scale and creating algorithms. So they are a customer of the data pipeline team, and that they take those raw signals and they turn them into valuable intelligence in the form of scores, in the form of topics. Then we have our data warehousing team. Our data warehousing team is responsible for coalescing those raw signals and the derived signals that the scientists produce and putting that together in a structure that allows our data consumers to be able to access and ad hoc query that data at scale.
So if I talked to you 5 years ago about combining open source software with Microsoft commercial software, you probably would have laughed or you would have thought that it wasn't possible. But today you're doing it. So why does this work?
It's first of all, it's using the best tool for the job. And when you look at the requirements, open source and Hadoop allows us to inexpensively store data at scale and scale it up very easily by adding additional nodes to our clusters. So we have an inexpensive way of expanding data because data continues to grow. So that's a great tool for that job. But it's not a great tool for doing analysis. Commercial tools, especially Microsoft Business Intelligence, is a great tool for doing analysis at scale. So it's a great tool from the performance of a query and how fast and how much data that you can query in real time. But it's also very valuable from a compatibility standpoint. So there's a whole ecosystem around commercial tools, especially Microsoft Business Intelligence, that allows you to do visualizations, to do reporting, and to do publishing. And that's really valuable, and it's not something that I want to roll on my own.
So you've talked here about 3 teams, really. And how do you think about these 3 teams, either in size or maybe in skill set? Are they all the same size, for instance?
Really, right now they're relatively sized the same. But what we see is because we're capturing as data and looking at activities across as many networks as possible, because we want a complete view over that user, that registered user, to give them credit for their influence across all the forms of social media. So we have to capture a lot of networks, and those networks are all custom APIs. So each network has their own way that they're going to publish their data, and those data elements are all going to be custom. Those signals are going to be custom to that network. So really, that data capture and storage is probably the largest team in the long run. Because once the data is normalized and fed into our pipeline, our scientists and our analysts can use the same tools that they invested in to process and move that data and make it into actionable information.
This probably is very similar to what our CIOs here are experiencing, where often you say, bad data in is bad data out, or there's a lot of great sound bites for that. And I think in your case, what I'm taking away, as it is external APIs you're having to deal with, for CIOs building systems internally, the ETL and the integration of the data is probably the most critical work that they've got to do, rather than just getting excited about the front end and the analysis, essentially.
And it's a data capture, and the data capture is because these networks, in our case, the networks are changing on their own cadence without any kind of notification to us. So that's where it's really important from a data quality perspective to have the proper monitoring in place and to be able to track those changes before they actually update a score or update topics, which would result in bad data or a bad experience for our consumers. So analysis services and being able to look at that data at scale and compare trend lines and look at data across time, across different time dimensions is critical. And to do that, you really have to have a great analysis system to be able to find those patterns and detect anomalies in those patterns.
Dave, thank you very much for your time. You've given us a lot to think about here. For people that want to find out more, you can go to klout.com, Klout.com. Until next time, I'm Bernard Zizan.